Okay, hello and welcome. So I am Haryo Wicaksono. I am currently participating in a data science course. I'm as a virtual exchange student in Asia University. My my student number is 110 710 461, and we are actually doing a an implementation of performance evaluation of supervised machine learning models. So it is actually a comparative study on various binary classification algorithms for breast cancer detection. Okay, so in this video, I'm just gonna introduce you to like an outline to the course which I will be teaching. And before we start, I would like to mention that um, there are previous courses explaining the same exact algorithms that we use on a more theoretical basis. And there's also like a Python tutorial um, that implements like various machine learning from the basics to like implementing various machine learning algorithm stuff. Okay, so uh, yeah, and then I would actually recommend whoever's watching this to watch those first, so like you would have an underlying understanding of what I'm gonna be talking about. So yeah, without further ado, I'll just try to introduce like essentially um, the yeah the the outline. Okay, and please take note that the code will be available in the description, and this file as well will be accessible in the description as well. Okay, so yeah. Okay, so we start with data preprocessing and importing libraries and stuff like that. So we have pandas, numpy, and scale-learn. Okay, and then we import the data set as well. Uh, so like I'm gonna have like I'm gonna have a specific video explaining about the libraries that we import as well as the dataset as well. The dataset itself will be explained in a more um, yeah, orderly fashion, I suppose. Yeah, and yeah, but essentially it contains 10 features describing like the cell nucleus of cancer cell, and it and then we would have three types of those each of those features, right? The mean, the standard error, as well as the worst or like the mean of three largest value, right? Of those yeah of the data, and we would have 569 rows, so like it's not actually very big, the data set itself, but yeah, all in all it has 30 features, right? So yeah. Okay, and then first, we in data preprocessing, we are gonna handle missing values. That has something to do with deleting rows and columns with missing values, or we impute the missing values, right? And imputing depends on like whether or not it's continuous or categorical. We can also actually use so like I want to actually provide like an underlying like understanding and an underlying concept, and then I would actually implement it later on in the code itself. But I would actually explain the different alternatives that we can actually use, right, to solve our problem. So, and then next up we have algorithms that support missing values. So here you don't actually have to impute, right? So, and then we have the prediction of missing values. So we, instead of just imputing with like mean, median, or mode, we can actually predict the missing values. And yeah, we can also impute using deep learning library. Okay, and then we have data cleaning. Data cleaning actually involves removing irrelevant data, removing it's like those features that we just don't use, or like the rows that we don't use, or like very incomplete, right? It can actually be um, removed. We also remove duplicate data. So yeah, and sometimes, like for example, a user may press the submit button twice and it gets recorded, right? So yeah, and then we do type conversion. We handle syntax errors, right? Handling syntax errors, and then we do feature scaling. Yeah, and I'm gonna explain like for each method. I'm gonna explain it thoroughly, so don't worry. and then uh, we can do categorical. We will do categorical encoding as well, and I'm gonna explain the methods as well. And yeah, okay. And then I'm going to talk about performance evaluation measures. Let me just make it simple. Methods or measures. Methods or measures, right? First up, we have accuracy, we have precision, we have recall, we have F1 score, right? We have IORC, yeah, and then we have fitting time and scoring time. So like the main five performance evaluation measures are the first five, and then I decided to actually include fitting time and scoring time as well, just for another consideration, right? Because later on we're gonna be, I suppose we're gonna be dealing with like whether or not, so like the dilemma between like performance or quality, right? Like for example, if you don't have like uh, a powerful computer, for example, like you probably want to choose performance, but like if you are, but ideally, right, when you have like a proper computer, right, a computer that is enough to handle a large data set, like you would want to have the best one. So and that's going to be available in the conclusion as well. So yeah, suppose that's probably it. And I'm going to talk about cross validation, what it is, and then how it works and the different types as well. We have like stratified k-fold cross validation. We have the repeated k-fold cross validation as well. And we're going to talk about dimensionality reduction. So I'm going to talk about what it is. I'm going to talk about the different measures that we can do to do dimensionality reduction. And then we're going to compare it, compare like with or without, with and without dimensionality reduction. So like our models, with and without dimensionality reduction, and see whether or not it does have any effect on it, right? And this is where fitting time and scoring time actually comes in handy, because it's gonna be very useful in deciding like, oh, okay, like is it actually working, because like obviously like the one with dimensionality reduction would have like lesser time, right? Lesser amount of time it takes to like do a model fitting or a model scoring. So yeah, so these are just like the steps with dimensionality reduction and without. And yeah, we also have the results and discussion. And yeah, so here are the results and the discussion as well, and as well as actually future work, like for example, what can evaluation and conclusion. Yeah, so it's more of an evaluation and conclusion as well. So yeah, um, I suppose that's it for this video, and I'll see you in the next one. And